Okay, this video is going to be focused on factoring special products. So go ahead and pause this and copy these formulas down in your notebook. The difference here is that notice we only have two terms. So it's not a regular polynomial, it's a binomial. There's just two. This formula works if you have perfect squares, meaning you can take the square root of these two numbers evenly. And it only works when they are being subtracted. So if this was a plus, you could not use this formula. And you take the square root of the first number, square root of the second number, and make one minus in the middle, one plus in the middle. Next, for cubes, if you notice that you have two perfect cubes, then you have a difference formula when they're being subtracted and a sum formula when they're being added. And you'll notice here, I don't know if you guys have heard of SOAP, but that means same, opposite, always positive. So notice how this sign is subtracted. So this is the same. This is your opposite, so it's a positive, and then always positive, okay? And same difference when it's sum of cubes, same sign, opposite sign, always positive. And these are just formulas. You take the cubed root of both of these numbers to come up with your A and your B value and simply plug them into the formula. So it looks overwhelming, but you'll see that these are actually the easiest type of factoring. So let's get started. Okay, notice for our first example, they are both perfect squares, right? I can take the square root of 4, it gives me 2, and when I take the square root of x squared, I end up with an x. And when I take the square root of 9, I end up with 3. Well, you've already got your A and your B. So we can take 2x minus 3, and then we need 2x plus 3, and you're done. So again, just to reiterate, you take the square root of both terms and plug them into your formula, one positive, one minus. All right, let's take a look at the next example. Square root of x to the 4th, we can do that. Square root of x to the 4th is x squared. And then the square root of 64 is 8. So again, that works out perfectly. We have our first value, our A and our B. X squared minus 8, x squared plus 8. And if you wrote those differently, if you did x squared plus 8, x squared minus 8, you're totally fine. They're the same thing. And if you're like, well, wait, can't I keep going? There's two terms. You can't because you don't know what the square root of 8 is. That's not a perfect square. So this would be as simplified as you'd want to leave it. Okay, the final example, x squared plus 49. You're like, oh, perfect. I've got two squares. I can take the square root of x squared, that's x. I can take the square root of 7. However, that plus sign in the middle is not a subtraction. There is no sum of squares. So this, we would say it's prime. Okay, the only formula works if there is a subtraction sign. So don't get, this one's kind of tricky. All right, let's do the next example. Now we're going to do sum and difference of cubes. So again, we have two terms. However, you'll notice that our exponent has a 3. So instead of taking the square root, we're going to take the cubed root. Okay. Cubed root of x cubed is x. Cubed root of 8 is 2. So we now have our values for A and B. And we need to come to our formula and think, are we going to use difference of cubes or are we going to use sum of cubes? Well, for this first one, it's a sum. There's a plus sign in the middle. So now you are going to take your two values for A and B and simply plug them into the formula. All right, So my first is just going to be x plus 2. Next up, we have a squared. So you're going to take this value and square it. Minus a times b. So multiply 2 times x. Plus b squared. So plus b squared, 2 squared gives you 4. And you're done. So it really is simply plugging everything into these formulas down below. All right, let's do one more. Now we have a cubed minus 27. So let's find out what our two values are. We can take the cubed root of a cubed, that gives me an a. And we can take the cubed root of 27, right? Cubed root of 27 gives you 3. So we now have our values for a and for b. Notice how this is being subtracted, so we're going to use the difference of cubes formula, this one right here. All right, so let's plug everything in. We have a minus b, so a minus b. Next up, we have a squared, so a squared, plus a times b, so plus 3 times a, plus b squared, so plus 3 squared, which gives you 9. And you're done.